Hi everyone, we're going to prove the inequality for the indicated integer values of n by using the extended version or extended mathematical induction. And this is our sequence or our series. And what we're going to do is first try condition 1, where we're going to start with n equals 2. So I'm going to put add the first two terms here, and when I add those, so that's 1, it's going to be 1 plus 1 over square root of 2, and that should be greater than the square root of 2. And when you do this, we're going to get, this is approximately 1.707, and the square root of 2 is approximately 1.414. So it holds true for condition 1 when n is 2. Now for condition 2, we're going to go ahead and write it with n equals k. So we have 1 over square root of 1 plus 1 over square root of 2 plus 1 over square root of 3 plus dot 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 1 over square root of k is greater than, it's going to be greater than the square root of k, and we're just going to say n is greater than, or k, sorry, is greater than 2. Okay, then on the next slide I'm going to show n equals k plus 1. So we want the next term here. I'll put it over here. So we're going to get 1 over square root of 1 plus 1 over square root of 3 plus dot 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 plus 1 over square root of k. And our next term would be 1 over square root of k plus 1. And then that's going to be greater than square root of k plus 1. And that's going to be where k is greater than 2. Alright, now we already know that this whole amount is greater than square root of 2, so we're just going to write this as square root of k. That equals which was the square root of k, which we had on the previous slide. And then we're going to add our next term, which is 1 over square root of k plus 1, which is greater than the square root of k plus 1. Alright, so, and this is where k is greater than 2. There's a dot. Alright, now what I'm going to do is multiply everything through by k plus 1. Just to simplify this. So I'm going to multiply everything with square root of k plus 1. And what you're going to get is when you multiply this, you're going to get square root of k times the square root of k plus 1. I'm just going to leave it like that, and then I get plus 1. And when you multiply, because these will cancel, when you multiply these two, that would be like square root of k plus 1 squared. So that's going to get rid of the radical. So let me write it again. Alright? Now, the way I'm going to write this now, I'm going to just deal with this side because we're trying to prove that it's for all possible integers n. Instead of the k being written like that, I'm going to write it as square root of k times the square root of k plus 1. Now let's compare both sides. That should be a little bigger. And if you notice here, these match and these match, but this side is going to be bigger. This term is going to be bigger than this side. So we have proven that our statement that this is valid, our first term. So basically 1 over square root of 1 plus 1 over square root of 2 plus 1 over square root of 3 plus ... plus 1 over square root of k plus 1 over k plus square root of k plus 1 is greater than the square root of k plus 1. And we're done. Thank you. Have a nice day. Bye-bye.